Okay, I was asked to do problem number 6, or just show you how to do it. Number 6, again, we got to set up a proportion before we even solve this guy. Alright, so let's look at what they're giving us. They're giving us cylinder A. So all of these are going to end up looking like this. Look equals one over the other. And it's always the first over the second. Okay, so if that's the case, the first is your cylinder A, your second is cylinder B. Okay, so that means that you have 32 over 24. Now this needs to be simplified before we can continue. So this, if we simplify it, becomes 4 over 3. Okay. We have our A, our B. Now, what is the question asking? They're asking for surface area. So that means that we're not looking for this one, because this one we have already. We're actually looking for this one, a squared to b squared. So, if that's the case, well, we have to change, because this is A and this is B, we have to change to this. So the proportion we're actually working with is going to be 16 to 9. The last thing says, if the cylinders are similar, find the surface ratio of cylinder A to cylinder B. Back. So the last problem we worked on was on homework 11. This next problem I'm working on is on homework 12. It is actually number 12. We're looking at how many times larger is the volume of a cone if the height is doubled. Remember, these are the ones where you actually choose the values that you're going to put into these variables. So make it easy. Let's do number 12, and instead of making numbers hard, let's just say, first of all, we need to know what's the volume of a cone. Well, the volume of a cone is 1/3 pi r squared times height. So in reality, we need these two right here. Okay, so why make our life difficult? I'm going to say the radius is going to be equal to 1 and the height is equal to 1. Okay, so the first radius, the original radius, if you want to call it, over the change, or hold on, let's figure this out first. We're going from, we're going from smaller to larger. So yeah, we're going to have the, let's fill this guy out. And I'm not going to solve pi. I'm just going to leave it there. So these two equal 1 times, so we're left with 1/3 pi. That's our first volume. So our first volume, I'm going to call it volume 1, is 1/3 pi. So it says here that the height is doubled. So what we're going to do is our new height is going to be, if I double that, is 2. Super easy. So now we fill it out again. So 1/3 pi times the radius squared times the new height. So if we resolve this, this becomes 2 times that. I'm going to get 2/3 pi. So volume 2 is 2/3 pi. Okay, so we want to find out what our change is, or how much it grew, or it became smaller. Well, it went from smaller to bigger. So that means if it went from smaller to bigger, we're going to have to do 2/3 divided by 1/3. And if we take care of that, our answer is 2, or 2 times